Hello. In this lesson, we want to examine alternate exterior angles. Remember, the exterior portion of our diagram is the portion that's outside the parallel lines. So we have exterior region up here, all of this region above the parallel lines, and all of this region below the set of parallel lines is considered to be exterior, outside the parallel lines. Alternate, again, meaning on opposite sides of the transversal. So we have, again, two pairs. We have angles 1 and 8 that satisfy alternate exterior angles. That's a pair. And we also have a pair of alternate exterior angles 2 and 7. Okay, so we have always two sets of these alternate exterior angles. Let's look at some specific numerical examples. The diagram on the right-hand side, you can see that the alternate exterior angles in question here are angles 1 and 3. Those have the same measure. Well, we can use some logic starting with the information that we do know. We know this angle is 47. And on the previous page, we talked about alternate interior angles. We would know that if these lines are parallel, that measure of angle 2 is also equal to 47 degrees. I'm just going to put 2 equals 47 degrees, but I mean the measure of angle 2 because of alternate interior angles. Then we can use logic to realize if 2 is 47 degrees, angle 3 is also equal to 47 degrees in measure because it is a vertical angle to 2. And lastly, angle 1 is also 47 degrees for either the vertical angle reason or that angles 3 and 1 are alternate exterior. Let's take a look at an algebraic example. In this diagram, we have one pair of alternate exterior angles marked, and the lines are parallel, so we know that those are equivalent in measure. Our relevant algebraic equation would be that the top left angle, 3y plus 53, must be equal to the bottom right, 7y minus 55. All right. Applying a little algebraic manipulation here, we can subtract 3y from both sides. And let's also at the same time add a value of 55 to both sides of the equation. The reason we're doing that, it will zero those terms out. We will zero those terms out. And once we add here, we have a much simplified equation. On the left-hand side, we have 108. On the right-hand side, 7y, take away 3y is 4y. Once again, we're going to divide both sides by 4, coming up with a y value of 27, if I didn't make a mistake there. All right, and one way to make sure that you didn't make a mistake is to go ahead and plug that in to find the measure of the angle. In this diagram, I want to find the measure. So we'll take that value of 27, plug it in for each of these y values, and see what happens. So the top left, we have 3 times 27 plus 53. 3 times 27, 1, carry my 2 is 81 plus 53. And we add those two together and we get 134 degrees. All right, let's take a look and make sure that's the case on the bottom right. We have 7 times 27 minus 55, or 7y minus 55. 7 times 27, let's see, that would be carrying my 4. So I have 189 minus 55. I'm going to go ahead and write that below it. And when we subtract there, we can see that we have, in fact, 134 degrees. Feeling pretty good about it. It's a match.